Let's continue our discussion on superposition of waves. And this is lecture number
4, 3, 4, I think.
lecture 3 na? Lecture 3.
Yes, sir, lecture.
And last time we discussed the static waves, right? Did I talk about the distance between node and antinode and node? Yes, sir. The n and n plus 1 and all those things we discussed that. Then let's have this discussion on normal modes. On
Second
a
is
stretch string.
Second means 5.
Normal modes on a straight string. So let me make some diagrams and then you tell me what should be the correct condition. So let's say you have two walls and in between them there is a rubber band or some kind of string. Yes? And then you pluck it. You pluck it at different positions such that you have one of the waves something like this. Maybe something like this. Okay? And let's say the length of this thing, the length of the rubber wire is length L. So length of string is L. Let me take that. Then in terms of the wave, can you tell me what is this length? How much does this? What is this length? Huh? What is this length? If I complete this wave, then it should be
Lambda.
this is lambda, and then what is this?
Lambda by 2.
Lambda by 2. Then what is the condition that the green wave is following? Then lambda by 2 is equal to L now, in terms of length. Let me take one more wave and something like this. Could be something like this. Then what is the condition that it is following? What is this length?
Lambda.
That's lambda, no? The lambda is equal to L this time. Yes or no? Let me take another color, the last one, and let's say I make a wave something like this. Then what will that follow?
3 lambda by 2.
That should be 3 lambda by 2. Yes or no? And that should be equal to L. Then can you see a general pattern that the waves are following? That the general pattern, the condition on the wavelength is something like this. That n lambda by 2 has to be equal to L. Where n can be what? Should it start from 0?
No.
It starts from 1. And then what is the lambda? What are the permissible lambdas? It's 2L by n. So just by looking at it, can you see the generalization? If I put n equal to 1, then am I getting this L by 2, lambda by 2? What about n equal to 2? Lambda. N equal to 3? 3 lambda by 2. Then this is a condition on the waves that can form inside this cavity now, or maybe this kind of structure, that any kind of wave which is going to form inside it has to follow this condition, n lambda by 2 is equal to L. Yes? Then let me call it lambda n, subscript lambda n. Then if this is a condition of wavelength, by the way, all the waves are moving in the same medium now. Medium has not changed, that means the velocity will be the same. The velocity will be the same for all of them. So Vn is equal to V for all of them. Then what is the relation between Vf and lambda? V is equal to F lambda. Yes? Then what is F? That's V by lambda. Then what is the frequency of the n? So this n corresponds to the mode. The first, that's why I wrote normal modes. Okay? N equal to 1, let me write it. N equal to 1 Then this is the first mode. It's also called the first harmonic or the fundamental tone. Fundamental tone or first harmonic. Some names, okay, just have to remember the names. When n equal to 2, then what is that called? It's called the first overtone or the second harmonic. First overtone or second harmonic. And then can you guess what should be n equal to 3?
Second overtone.
N equal to 3 पे?
Second overtone.
Second overtone and
Third harmonic.
third harmonic. These are just names, just names that you just have to remember. So for all modes there are some n value and that will correspond to and so on. Okay. Then what will be the f? The fn will be equal to v by lambda n. But what was the lambda n that we found out? That's 2l by n. Take the reciprocal. nv by 12. And this is the frequency of the nth mode. Yes? Frequency of nth mode or nth harmonic. Do you understand? These are all possible waves that can form, and what will be their corresponding frequency given us? They are given us by this formula. Acha, what is the velocity of a wave on a string? What is the formula for that? Velocity of a wave on a string?
Root T by mu.
No, everyone should know this.
Root T by mu. Root T by mu.
Why are you turning the pages?
Root T by mu.
Root T by mu. That's very simple. V is equal to root T by mu. Then what should be Fn? Can even be written as n by 12 root T by mu. Do you understand? And please remember that the velocity will not change. Even though the number of lobes may increase, this n value will change, maybe third harmonic, second harmonic, the velocity will not change. It's the same medium, same tension again. Does it make sense? Okay. So this is the frequency that we find. When n equal to 1, then the frequency is given a special name. It's called the fundamental frequency. Everyone has written up to here?
No, sir.
Should I wait some time? Acha, I also should have said this. If we have 4 lectures before your vacation starts, so the theory part will be done by the end of the today's lecture. We will dedicate 1 lecture for the problems, and then there will be 2 lectures remaining. And then what I want to do is, we have been talking for over a month now. So whatever I have taught, we will try to revise that in those lectures. Those 2 lectures will be dedicated to revision only of whatever we have studied up till now. If you have anything to complain about that, then you can say right now. Are you okay with that? Right. So, आज theory खत्म कर देंगे. I could start with a new chapter in the last 2 lectures, and then there will be a huge break, so no need of that. कोई meaning भी नहीं होगा उसका फिर. So written?
Yes.
What will this n equal to 1 yield? Can you see that? Fn में n equal to 1 डालो, what will you get? That will be v by 12 ना? So when n equal to 1, you get f1 as v by 12. But then you also always find v by 12 here. Then what is Fn? Fn equal to nf1. What is this f1 called? It's called a fundamental frequency. frequency. Do you see that? Yes? Good. Then if it is written, can I write one question? Let's do this one question. And then we will go with the problem part. Rather, we will go to the end of the chapter. It will be reflection and transmission. And there is a interesting discussion on resonance as well. So please remind in the next lecture that I have to talk about resonance. We talk about resonance a lot in sound waves. It's not the same resonance as you have studied in chemistry. So normal modes done. I should in general point out that the frequency is proportional to root T. That will be useful to us later sometime. Just remember that. Okay. So let's try this one question. Everyone remembers fluids ना? क्या फर्स्ट बैच के टाइम पास करोगे दोनों निकाल दो. So question. In the next lecture, I will give you a sheet as well. Actually, I already made a sheet, but then I found out the 2-3 questions I wrote incorrectly. So then वो कोई meaning नहीं होता उस sheet देने का. So I am writing the questions today. These are the options. I am giving you 4 minutes to think, attempt. minutes left. Any progress?
B.
Option B is incorrect. Should I help you a little bit? See, I just pointed out to you the frequency will depend on the tension. Yes? And what do you think will happen to tension as you immerse the whole weight inside the water?
Decrease.
It will decrease, huh? Why will it decrease? By Newton's second law. Can somebody tell me what force is acting?
Sorry. Answer A.
A is correct. Anybody tell me which force is acting?
Buoyant force.
Buoyant force. And now you have to take into consideration the buoyant force and then do the question. I'm still waiting. Attempt. That's why you should keep on revising whatever you have studied, even in 11th standard. You will need it in the questions of 12th standard. Should I start or should I wait? Wait. Okay, I'll wait 1 more minute. Yeah, I'll start. 12:17. It's 12:18. Let me start with it now. So it's given that you have an object. I hope everyone has at least read the question. Something like this. You have a ceiling from which you are hanging an object of mass m. Yes. And then what will be the tension in this thing? That will be mg by Newton's second law. And then what will you get? I think you will get F1, that's the fundamental frequency, as 1 by 2L under root mg by mu. Na? Yes? Let's leave it at this. And then look at the other situation. What is that going to be? You have again the mass which is hanging from some ceiling. But now this mass is also immersed in a container which has this water inside it. Half of the volume is inside it. And now tell me, what are the forces acting acting downwards, and a buoyant force, but in which direction? Upwards. A buoyant. And now what should I write? Should I write T equal to mg minus fb or fb minus fb?
T is equal to mg minus fg minus fb.
Should be mg minus fb. Why?
Because
If fb is greater, then it will just pull the whole thing up. Great. So what is fb equal to now? Anybody remembers the form of the equation?
Rho of volume.
Yes. Rho of whatever is the liquid times the volume of whatever is submerged inside the liquid times g, na?
yes.
So rho of water minus what is the volume submerged? That's half times g. This is volume. Is it okay? Yes. But then I can relate that volume to something else. Now look at this. For the body, the density is given to be rho. That's mass upon volume. Na? And volume equal to mass upon rho. But then volume by 2 is equal to mass upon 2 rho. And then what do I get? I will get something like mg minus mg rho w by 2 rho. Is it correct? Is it correct? Please
So
check.
just take the mass as rho v.
I took
Just take the mass as rho v, sir. M equal to rho into v.
m equal to rho into v. It's okay, I will do it like this. And then what will I get? Then what is f1 dash? Let me call it t dash. Huh? Then what is f1 dash? That's 1 by 12 root t dash by mu. But what is t dash? That's mg 1 minus rho w divided by 2 rho divided by mu. And then can I take the ratio of the two equations? And then what will I get? f1 dash by f1. Can you see that the 1 by 12 cancels? Mu cancels. And you can take mg common. So you can have a mg 1 minus 2 rho w divided by 2 rho divided by mg का root. And I think this also cancels. तो वो LCM लो और उसके बाद बताओ क्या है? f1 dash is f1, but what is f1? 300 hertz. 2 rho minus rho w divided by 2 rho. Any option matching with this?
Option.
I think option A matches, but then you have to know what is rho w. What is rho w? 1 in what units? Gram per
ml or centimeter.
centimeter cube. That's correct. Gram per centimeter cube. Then you can write this to be 1. So I think the first option matches. So it was a very simple thing. You just had to understand what is the formula of FV, or you had to remember that. और उसके बाद खत्म कर प्रश्न, कुछ है नहीं. Tension में change हुआ है बस. Write the solution and then we will go forward. If it is written, then tell me. I will give a homework question. this information is given, you should be able to do this question. So if you have written this thing, then let me go to the last topic of the chapter, which is the reflection and transmission of a wave. So jaldi jaldi haan chalo. Reflection and transmission of the wave. Can I start with the topic? If you remember, even for ray optics, we had a similar kind of thing, but there we did not use the word transmission, but rather we used the word refraction. Refraction was just going from one medium to another medium. Yes? And here we will use the word transmission. So, again you will have two mediums, medium 1 and medium 2. They are separated by some boundary. Separated by some boundary. An incident wave comes, and the wave is given something like this. Comes and it is represented by yi, that is the incident wave. Even in ray optics, I told you that when a ray actually comes and hits a surface separating two media, then there will occur two things: a partial refraction, partial reflection, and partial refraction. Something like this will occur here as well: partial reflection and partial transmission. Okay? So let me denote the waves. One of them may go like this, and the other may go like this. This is YR, the reflected ray, and the other is YT. Is it okay? I have given a very rough diagram of what is happening. But now when it encounters such a boundary, then what happens? What are the changes, or what are the changes in the features of the wave? And what do you mean by features? Wavelength, speed, okay, omega, these things are the features of the wave. From this you denote a wave. So let me talk about each one of them. Let's try to understand what will happen if you encounter such a boundary. Okay? The first will be speed. Speed of wave. And I have to redefine something. If you remember that when we were talking about ray optics, we said that a medium is called to be a denser medium when
refractive is denser.
when refractive index is more, or maybe the optical density is more with respect to the previous medium. Then you used to say such a medium is denser. But then a consequence of this thing was the speed of the whatever the wave is, the light wave, was decreased in that medium. Speed was decreased in the denser medium. This is what I told you. Then actually we will use that definition of a denser wave medium. A medium in which my speed of the wave decreases, that's called the denser. Okay? And a medium in which the speed of wave increases, that's called rare. I am not talking about refractive indexes or anything like that here. I am only comparing speeds. Is it okay? So the medium in which speed of wave decreases will be called a denser medium. Okay? And hopefully you can write the rarer medium yourself. Okay? Try to write it. So we are trying to compare speeds now. Now understand this. Let me also tell you this. When we were talking about light, then do you remember what if I take two mediums, air and water, then which one of them will be considered denser? Water, right?
Its refractive index is speed decrease.
Its refractive index is actually 4/3, and for air it's 1. So anything with respect to air, all normal mediums are basically denser with respect to air. When you talk about light, now let's talk about sound waves. What will happen for sound waves? What we find is that the sound waves move much more faster in water as compared to air. Now why is that? Anybody? We will try to answer
Because
that
it's more
question as
denser.
well in the sound waves chapter.
Because it's more denser.
Because the particles are much situated much more closer,
Yes.
and in air they are a little apart. So, ये particle का influence on this particle will take some time. But what about here? The influences will pass very fast. And then you can already guess that the speed of sound is highest in solids. Yes. So now, air will be acting as what medium for sound?
Denser.
It will act like a denser medium for sound. Do you understand? So, how are we defining the denser medium? Medium in which the speed decreases. So that also depends on what kind of wave you are talking about. Okay? So don't think in your mind that obviously in between air and water is denser. No, we are not talking about mass density or anything. We are talking about a wave and how it passes through a medium. Okay? Now, Acha, what can you conclusively say about the speed of transmission wave and the incident wave? Will they be equal in general?
No.
You can't say, na? You just can't say. Vi is not equal to Vt in general. Yes? So, in general, speed of incident wave is not equal to speed of transmitted wave. And let me use the terminologies or maybe the symbols Vi not equal to Vt. In general, when will they be equal? By the way, is there a case where they will be equal?
When both the mediums are same.
When both mediums are same, then they will be equal, right? Good. So it can be equal when medium 1 is equal to medium 2. What can you talk about Vi and Vr? The
They are
speeds.
equal.
Huh?
They are equal.
They are equal in general. Why?
Same medium.
They are existing in the same medium. Also, Vi is equal to Vr in general. And please don't come up to me later कि Vi equal to how can it be they are moving in the opposite direction. I am not talking about the velocity vector. I am talking about speeds for now. You can always write the speed, the velocity vector to be Vi vector as minus Vr vector, and Vi and Vt का same direction.
Is there a case where they are not equal?
Vi not equal to Vr, no. There is no case. Did you understand the discussion on speed of a wave? Let's go to frequency. What do you think about the frequencies of different waves? Will they change? When we were talking about ray optics, was frequency a variable? No. Frequency never changed. Frequency only depends on the source. It has nothing to do with whatever occurs in here. So frequency depends only on the source. On the source, and that means you can write Fi equal to Fi is equal to Fr, which is equal to Ft. Is there any problem in this statement? Write it, not write it. Don't want to write? You can always stay at home and do the whole thing yourself. There's no restriction for you to come. What will happen with wavelength? What will happen with wavelength? Do you think that will change? Will it change? So V equal to F lambda. F is not changing, but V is changing. That means lambda has to change. The RHS has to change. So V equal to F lambda. F doesn't change. V changes. That implies E lambda has to change. Implies lambda has to change. Now, what will be the? Acha, theek hai, by the way, I should also ask you ki, what will happen as a wave goes to a denser medium? Will the wavelength increase or decrease?
Increase.
Speed decreases.
How many of you are in favor of the increase? What about decrease? It should decrease, na? Because if V equal to F lambda, this is decreasing as you go into a denser medium, that means this is decreasing. It's obvious stuff.
Yes, sir.
Lambda decreases as wave. Don't come first bench. Denser medium. Is it okay? Great. That was a discussion on wavelength. Now, what will happen to phase? Let's talk about phase. Phase change. You remember that when you have a string and then you plug it somewhere, that the ray will or the wave will go hit the wall, it comes back, but it comes back with
Less intensity.
pi radians change, na? Flips, the whole wave flips. And why does it happen? So I have given you the reasoning. Newton's second and third law. There will be a reaction force. It will make the particle go downwards. Yes. Now understand this. Let me take the example of when we were talking about refraction. I gave you the example of tank going through, or maybe a car going through a mud. As a car goes through a mud, its speed decreases and it feels a resistance. Na?
Yes.
That resistance manifests itself in the form of some kind of influence of the particle. Okay? Now understand this. For the tank, that mud was the denser medium. Na? For the light, the water is the denser medium. Na? For sound, air is the denser medium. And what do I mean by a denser medium? The wave is slowing down in that medium. It feels the resistance. It can't pass that simply. It feels the resistance. That means the denser medium has a capability of flipping the phase by pi radians. It's the same thing as hitting a string low, also hit karo wall par. That wall will act like a denser medium and it will give the phase change. But now if you enter a rarer medium, will that have the same effect? The particles are flowing much more simply now. So is there any resistance from the medium onto the particle? No. So will it apply any kind of force onto the particle? No. So will there be any kind of phase change in the rarer? So when you go and hit a denser medium, you come back with a phase change of pi radians. When you hit a rarer medium, you come back with zero phase change. Okay? And phase change between what and what? You have to compare between two things. Huh? Between the incident wave and the reflected wave. So this is the phase difference. delta phi will be 0 radians when what?
Rare.
Do you understand?
Yes.
Please check if you have anything to ask, then please ask. This was phase change. Yes, obviously there can be observations the same and not the same.
It's the same for transmitted waves as well.
Not for transmit, because those waves can go like this. Whatever, you can imagine that they were just going. There can be a phase kickback.
Yeah.
So maybe the same thing that I told you before. कि ऐसे अगर waves आ रहे हैं, then they will be kicked back a little bit.
Yes.
So, but not by pi radians or by u radians. There will be some phase
We can't
kickback.
have
The wave will look like as if it is starting from here. If you remember, I talked about this when I was talking about
Refraction.
refractor space kickback. तो वो हो सकता है, but not this change. Yeah. Can I talk about the fifth point?
No.
Still writing? It's okay. Keep on writing. Fifth point is power. Now, can you tell me, what does the wave carry? It carries energy, na? Carries energy. Let's say you are holding 10, 100 joules of energy, and now at the boundary, what happens? It falls up into two parts. Some part of it is transmitted, some part of it is reflected. Maybe 30-70 or 50-50 or 10-90. But then it will always have to follow one principle. What is that principle? The conservation law. The conservation law of energy. Yes? Then by conservation of energy, what can I write? By conservation of energy, Yi or maybe no, sir, Ei has to be equal to Er plus Et. Yes or no? Er plus Et. Then, if I take per unit time, then what will it be?
Power.
That should be power. And what will it give? So that will be Pi is equal to Pr plus Q. This is the equation that it follows. Is there any problem here? Wait. I just want to talk about last point and then I will do one derivation, then we will be done. So can I write the point?
Yes.
That is amplitude. What will happen to amplitude? And this is very interesting. I am just writing the formulas now and then we will try to derive it later. It's something like this. When you hit a medium, the amplitude of reflected waves is given as V2 minus T1 or V2 plus T1 AI and AT equal to 2V2 over V1 plus V2 A. You understand what is AI? Huh?
Yes.
That's the amplitude of the incident wave and AR and AT respectively for reflected and transmission. What about V1 and V2? Those are the speeds of the wave in medium 1 and medium 2. Yes?
Yes.
You have to follow this formula. And now tell me, what will happen if V1 equal to V2? What will happen here?
Zero.
Zero amplitude.
AR will be 0. What about AT?
AI.
That will be equal to AI. And what is that case when V1 equal to V2?
Same medium.
They are the same medium. So if you have same medium, then there is no reflection obviously. It just passes. Passes with the same amplitude as before. If V1 is less than V2, then AR and AI have the same sign?
Yes.
Yes or no?
Yes.
If V1 is less than V2, if they have the same sign, that means what? Is there any phase change?
No.
Same direction?
Yeah.
There is no phase change. And V1 will be less than V2 in which case? When you enter a rare medium में speed increase हो जाती है ना? That's why V2 is greater than V1. V1 less than V2 बोले या V2 greater than V1 बोले एक ही है, ठीक है? So when will your speed increase? When you enter a rarer medium. When you enter a rarer medium, then what is the phase change? Zero. That we have already written. What will happen when V2 is less than V1?
Normal, like 180.
Yes. AR and AI have opposite signs now?
Yeah.
Yes or no? They have opposite signs. That means what is the phase change?
Pi.
Pi. They have the phase change pi. And when will that occur? When will V2 will be less than V1?
It
When
enters
you
the
enter a denser medium. So it all makes sense?
Yes.
So let me write all the cases. Case 1. If V1 equal to V2, that means AR equal to 0 and V2 equal to AI. And when case this occurs? When medium 1 is equal to medium 2. It only makes sense. Huh? What about case 2? If V1 is less than V2 greater than V1 less than, what will happen then? AR and AI have same signs. They have same signs meaning what? They have a phase difference of 0 degrees. 0 degrees. That means medium 2 is rarer with respect to medium 1. Is there any problem in this statement?
No.
Please check. And then what will be case 3? If V2 is less than V1, then AR and AI have opposite signs now. And what does opposite sign mean?
Medium 2 is denser than
Phase difference of
180.
5 degrees. That means medium 2 is denser with respect to medium 1. Please check all the statements and then ask if you did not understand. इसने मारा था तो मैं नहीं बोल रहा था मारा सीधा नहीं लेटर है कृपया एकदम सी शेप में बैठा है एरो में बैठा है ऐसे यस परपेंडिकुलर
video clip fully they can find it.
Yes, in terms of vectors, you can write it. You can imagine because they look like vectors. The results are exactly like that of vectors. They are not really a vector. amplitude is not really a vector. It makes sense. It only behaves like that. Can I go forward?
Yes. Yes.
तो ये मैंने फॉर्मूला तुम लोग के मुंह पे डायरेक्ट दे दिया. अब मैं इसको डिराइव कर. Do you want a derivation of that?
No, sir. Yes. Maybe.
How many of you want a derivation of that? I see 8 people. How many of you don't want it? Only one. हैं? क्या बोल रहा है गूगल? नहीं इससे हाथ उठाया था मैंने देखा. Steadiness. Derivation. नोटा जो करेगा बेटा उसको फिर इंडिया से निकाल दिया जाएगा. फिर तुम बांग्लादेशी हो. अरे यार ये YouTube पे जाने वाला ये नहीं होना चाहिए.
Too late.
कोई बात नहीं. तो I have to do this derivation. By conservation of energy, what was the statement that I wrote? That EI should be equal to ER plus ED, no? But then per unit time, what can I write? Now somebody will tell me what is the power carried by a wave.
Omega square A square B S.
Very good. बता दिया तुमने को.
Yes.
And what is the mu? Mu can be written as in terms of rho is na? Then I can even write power as half omega square A square
V rho D M rho.
Is it correct?
Yes.
Okay. Let me say V1 is the velocity carried in medium 1 and V2 is the velocity in the medium 2. तो ये बताओ ये क्या होगा? Pi कितना होने वाला है? Half. अच्छा omega will not change ना since the frequency is not changing. So I will write omega square. AI square V1 mu 1. Is it correct? V1 mu 1. That's equal to half omega square AR square. अच्छा V1 लिखना चाहिए V2 लिखना चाहिए reflected के लिए.
अच्छा reflected so same medium.
Same medium. V1 ना V1 plus half omega square AD square V2 mu. Is there any problem here? अब देखो ये omega square by ये कटा गया. And what can that mu be written as, by the way? What is the relation between Vt and mu?
V root. No.
V is T is over T.
V square T. V square T.
V square.
T by V square.
ठीक है? Then it can be written as mu can be written as AI square V1. और क्या बताओ? T by V1 square. अच्छा tension will be same throughout the whole thing, ना? So that will be equal to AR square V1 T by V1 square again plus AT square V2 T by V2 square. And now ये tension भी कट गया पूरे.
Tension water.
ये इससे कटा. Yes or no? And then we find one final relation.
Sir,
AI square बोलो.
tension changed when we put it in the water, right? So it will depend on the medium. I don't know.
देखो, if we go into some other medium, then what does change? The change is in the velocity.
Yes.
The change is in velocity. And this, so बताओ, mu will change as you go into some other medium. Mu will change. So let's say you go into a denser medium, so mu will increase. So ये that decreases.
T is constant.
So it has nothing to do with tension here, na?
But we just calculated it in the before question, right? When we put the steel rod in water, the buoyancy force also acts and the tension decreases.
We did do that.
That is for frequency. That is for frequency, like it's the
Right.
relation for frequency.
yeah. This is if this increases, this also
Wait, let me think.
question is this also this is
You have two mediums and the wave is passing. Actually, by the way, I should not see. I am taking a very special example where I am taking a string. Need not be a string. And I am taking a transverse wave. Again, it need not be a transverse wave. The final form that we will find, that expressions that we found, has nothing to do with transverse wave or longitudinal wave. They are in general true. So, intention का कुछ है problem. Let's consider it to be constant right now, and I'll try to answer it later. The AR square by V1 plus AT square by V. Equation number 1. This is one equation, and now the second point of why we are doing the whole derivation. Look at this. When you have let's say you have this boundary which is separating the medium, you have an incident ray, this comes, there will be some reflected ray, maybe something like this, and there will be some transmitted ray, some other thing. Then let's say there are some particles, let's consider these particles either and either. Then what is the influence? So understand this incident ray is not at one instant, keeps on coming from a sources. So at all times there is an incident ray and a reflected ray. And what is the point of a wave? It oscillates the particles. And what will be the net effect of a particle here? It will be oscillated by the superposition of the two waves. Because both of them are influencing this particle. Then what will be the net displacement? Some y1 plus yi plus yr. That is the net displacement of that particle at this point, because it's being influenced by two waves. What about the particle here? It is influenced by one wave only. That's yt. Yes or no? And now, if I place these particles very, very close to each other, such that they are overlapping at this boundary, then should I find this value to be equal to this value?
yes.
Obviously I should, because if I find this value to be somewhere here and this particle to be somewhere here, then I am imagining that the particle is at the two different positions at the same time. That should not be true. They should be overlapping at some point. So this displacement has to be equal. What does it mean? That in general at boundary, this is called the condition of continuity. I don't know if you know this or not, but even in functions you write this LHL equal to RHL. And the function has to be continuous, it should not be broken. Something like this, yi plus yr is equal to yt at all times. Okay? At all times. So time is not you are not fixing time, it should occur at all times. At all positions as well. ये boundary को मैंने आगे पीछे shift कर दिया तो ये continuity break हो जाएगी क्या? No, it has nothing to do with the position of the boundary. It has nothing to do with the way in which you define your coordinate system. I can even write like this: yi equal to x comma xl t plus x equal to l comma t, which is equal to yt x equal to l comma t. Or you can equally write that's 2l or maybe l0. At all positions, the boundary can be shifted and the continuity should be satisfied at all points. Do you understand? I can shift my coordinate system or my boundary. Anyways, let's do the calculation for t equal to 0 and x equal to 0. And I'm not doing the whole exercise, but you will find this. That you will find the AI plus AR should be equal to A. You will find this. This is my second equation. So if I say I have two unknowns which are AR and AT, and I solve this for AR and AT, then you will get the formula that we had. AR equal to V2 minus V1 by V1 plus V2 AI. AT equal to 2 V2 by V1 plus V2 into V. I'm not doing that as well. You should do this. Try to do it yourself. Did you understand the whole thing?
Yes.
Whatever we did.
Sir, for AR there's a minus sign.
What?
For AR there's a minus sign.
Where? Here.
No, up.
Here.
No. Yeah.
Either minus sign or C. Why?
Sir, before you took minus V1 or something.
Minus V1.
While taking the power.
I don't understand. Power में
The minus V1 mu
Sir,
down.
Down.
that's not minus. ये जा नहीं रहे हो. ये V1 है. कुछ नहीं है. वो जा नहीं रहे. एक्चुअली वो प्रॉब्लम है. ठीक है V1 ही है वो. Is it okay? Copy. And when you are done with this, then that's the end of the chapter. तो बच्चों को लिखना है. आखिरी लिखना है. कोई बात नहीं. Right, everyone? So by theory part I am done with the chapter. There's a small topic of resonance that I will talk about. Actually it's a very interesting topic that we'll study in sound waves much more, even in alternating currents later. But abhi ke liye I will just introduce the idea, and from next lecture on, in the next lecture only we'll do problems, and that will be the end of the chapter. Okay, so you can switch off the thing and then